It wasn't a sudden split-second event. Humanity's close call stretched on for 117,000 years, an age of barely holding on. And here's the wildest part. Nobody even knew this had happened until 2023. For decades, scientists suspected our species had gone through some kind of population crash deep in the past. The clues were there. Compared to other animals, humans are strangely uniform genetically. Take chimpanzees. They live in scattered groups across Africa, yet their genetic variation is far greater than that of all 8 billion humans alive today. That's not normal. That's the unmistakable fingerprint of a bottleneck. But just how severe was it? How close did we come to vanishing? No one knew. Not until recently. The story begins with a researcher named Wang Ju, at the Chinese Academy of Sciences. About 5 years ago, he was running genetic analyses on modern human populations, searching for patterns in our evolutionary history. What he found would rewrite the story of us. Right now, more than 8 billion people share this planet, in cities, on farms, across mountains and deserts. We've built towering skyscrapers, launched rockets toward Mars, and woven the internet into daily life. No other species has ever shaped Earth the way we have. But imagine the world 900,000 years ago. A startlingly different scene. Instead of billions, there were only about 1,280 of us, breeding individuals, alive worldwide. Not 1.28 million, not 128,000, just 1,280. The sheer fragility of that number makes it almost unbelievable that we survived. The entire future of humanity was balanced on a thread so thin you can hardly picture it. If you listen to pieces like this to fall asleep, that's exactly why I make them. So subscribe if you like, and tell me where you are and what time it is. I read the comments and it's always everywhere at once. Berlin at breakfast, Boston at bedtime. You ever get that jolt when you narrowly miss a crash? Slam the brakes and a truck skids past by inches? That's what our species went through, a near miss on a planetary scale. Calming, bedtime rewrite tonight. Close your eyes and picture Earth as it is now. Over 8 billion people filling cities, fields and wild places, building, exploring, connecting. It's easy to take that vastness for granted, but if you step back nearly 1 million years, the scene is much smaller. Only about 1,280 humans remained, just enough to keep the line going. That tiny number makes our survival feel miraculous, a single fragile thread stretching across time to where we stand now. That sense of how close we came can be strangely comforting, especially when you're trying to sleep. It's like the deep breath after narrowly avoiding an accident, a reminder of how precious and improbable existence is. If you enjoy these, subscribe and tell me where you are and the time. I always love seeing Berlin at breakfast and Boston at bedtime all mixed together. Rest easy. We made it through once, and here we are. Standard stuff at first. Sequencing DNA from over 3,000 people around the globe, tracing mutations backward through time like a molecular clock. But then something strange appears. Around 900,000 years ago, the genetic record doesn't taper. It collapses. It's like watching a film where suddenly 99% of the cast vanishes from the screen. The models are screaming that something catastrophic happened. But the signal is so extreme that he doesn't believe it. Maybe it's a glitch. Maybe his analysis is wrong. Because if the math is right, our ancestors were reduced to fewer than the number of students in a typical high school. So he spends years checking, rechecking, switching methods, running the numbers again and again. Every time the result comes back the same. About 98.7% of human ancestors disappeared around 930,000 years ago, and the survivors remained critically few for over 100,000 years. To put that in perspective, that's longer than modern humans have even existed as a species. And no, this wasn't just a rough patch. In biology, once a population dips to around 1,000 individuals, it usually doesn't recover. Genetic diversity collapses, inbreeding accelerates, random disasters can wipe out the entire group. Scientists call it the extinction vortex. Most species that fall into it never climb back out. But somehow ours did. For 117,000 years, a fragile thread of early humans endured. Through ice ages, through crushing droughts, while countless other species disappeared forever. Against all odds, that tiny remnant carried us forward. Who knows where? keeping the flame of humanity alive when it should have been snuffed out. What makes this discovery even more incredible is the timing. 900,000 years ago puts us right in the middle of what geologists call the early Middle Pliocene transition. This was when Earth's climate went completely insane. Before this period, ice ages came and went in relatively predictable 41,000-year cycles. The planet would get cold, ice sheets would grow, then things would warm up again. Tough but manageable. But around 900,000 years ago, everything changed. The ice age cycles shifted to brutal 100,000-year patterns. Glaciers became massive, covering huge chunks of the northern continents. Sea levels dropped by hundreds of feet. Ocean temperatures plummeted. And in Africa, where our ancestors lived, the climate became incredibly harsh and dry. Picture this. You're an early human, maybe Homo erectus or one of their descendants living in what used to be lush woodland. Over generations, your world is transforming into an arid wasteland. Water sources are disappearing. The animals you hunt are disappearing. Plant foods are growing scarce. And it's not just a bad season. It's getting worse, and it keeps getting worse for thousands upon thousands of years. Scientists call this kind of collapse a perfect storm for extinction, and that's exactly what happened to most human populations of the time. They vanished, but not all. Somewhere in Africa, a tiny group managed to survive. We don't know where. We don't know how. But they endured. And here's where the story bends into the extraordinary. During this long bottleneck, something unprecedented happened inside our DNA. Two of our ancestral chromosomes fused, merged into one. That's why modern humans have 46 chromosomes, while our closest relatives, chimpanzees and gorillas, have 48. Chromosome fusion is incredibly rare. It's the kind of event that happens maybe once in millions of years, yet it happened right in the middle of humanity's near extinction. Coincidence? Probably not. When populations shrink to just over 1,000 individuals, strange genetic shifts can sweep through the entire group with surprising speed. If even one survivor carried this chromosome fusion and had children, that mutation could spread rapidly. In a population so small, within a handful of generations it could become universal. And that's exactly what happened. Today, every single human alive carries that fused chromosome, a permanent scar from the moment our species nearly ended. All 8 billion of us carry the mark of that struggle. It's written on chromosome 2, the fused chromosome that bears the genetic scar of those desperate 117,000 years when humanity almost vanished. Scientists can actually point to the exact site where the fusion occurred. The molecular seams are still there, like forensic evidence from the most important crime scene in human history. But this fusion didn't just shrink our chromosome count. It may have changed everything. Genes clustered near the fusion site are linked to neural development. Some researchers believe this rare accident could have nudged our ancestors' brains toward greater size and complexity. Think about that. Our capacity for language, for music and art, for abstract thought, for building rockets and writing stories. It may all trace back to a single genetic accident, carried forward by fewer people than could fill a small town. The evidence of this bottleneck is still inside us, preserved in our DNA like a time capsule. Every living human carries the molecular imprint of those 117,000 years of survival. Population geneticists can even see it in the mathematical patterns of our genetic variation, a fingerprint of near extinction. But here's the twist. For decades, that fingerprint was invisible. Early genetic tools were too crude, like trying to read an entire book through a keyhole. The signal was always there. We just couldn't see it clearly enough to understand. For years, scientists knew something had happened in our past. The genetic record clearly showed at least one population bottleneck, probably when humans first left Africa around 60,000 years ago. But no one realized there had been an earlier, far more devastating one. The breakthrough came with new computational tools, like the FitCol method developed by Wang Jie and his team. These techniques could sift through thousands of genomes at once and trace genetic changes nearly 1 million years into the past. When Wang Jie published his results in Science in 2023, the reaction was shock. It wasn't just the severity of the crash that stunned researchers, but its length. Most bottlenecks in evolutionary history are short and brutal. A volcanic eruption wipes out a species, or a disease kills 90% of a population, but within a few generations the survivors rebound. This was different. Humanity's bottleneck lasted 117,000 years. That isn't a crash followed by recovery. That's a prolonged species-wide near-death experience. Nick Ashton, an archaeologist at the British Museum who reviewed the study, put it bluntly. This would imply that the surviving population occupied a very localized area with good social cohesion for it to survive. Of greater surprise is the estimated length of time that this small group survived. If this is correct, then one imagines that it would require a stable environment with sufficient resources and few stresses to the system. In other words, somewhere in Africa there must have been a refuge, a rare pocket of stability where a small band of early humans found what they needed while the rest of the continent was hammered by climate change. But where was this refuge? What made it different? And how did fewer than 2,300 people manage to hold the line for over 100,000 years? Those are the questions that keep scientists awake at night. Some researchers think the survivors clung to life near dependable water sources, perhaps the Great Lakes of East Africa, or rivers that kept flowing even when the climate grew harsh. Water attracts animals. Animals mean food. And together, food and water mean survival. Others suggest the survivors possessed technologies their cousins lacked. Chief among them, fire. Mastering fire is a turning point in human history. It lets you cook food, unlocking more nutrients. It drives away predators. It extends the day, giving you more time to work, plan, and socialize. Most importantly, it makes otherwise hostile environments livable. Archaeological evidence shows a sudden surge in the use of fire about 800,000 years ago, almost exactly when the genetic bottleneck ended and human populations began to recover. Coincidence? Probably not. But here's the detail that truly reshapes the story: the fossil record. Between about 950,000 and 650,000 years ago, there's almost nothing. Anthropologists used to call it the fossil gap, a baffling absence of evidence across Africa and Europe. Now the explanation seems clear. There simply weren't enough humans around to leave fossils behind. With perhaps only 1,280 breeding individuals scattered across vast territories, the odds of any one of them dying in conditions suitable for fossilization were vanishingly small. It's like hunting for needles in a haystack, except there are almost no needles, and the haystack is the size of a continent. The rare fossils we do have from this time mostly come from Europe and Asia. That suggests they represent populations on the margins, groups that weren't part of the core, African survivors who carried the line of humanity through the bottleneck. It's possible the population crash didn't hit every group of early humans equally. Africa is vast with wildly different climates and ecosystems. Some regions may have become uninhabitable during the climate crisis, while others remained stable enough to sustain small groups. But the genetic evidence leaves little room for doubt. The ancestors of all modern humans, Neanderthals, and Denisovans passed through the same narrow bottleneck. We are all descended from those 1,280 survivors. Every person alive today carries DNA from that tiny group who endured the harshest climate collapse in human evolutionary history. In the process, we lost about 65% of our genetic diversity. To put that in perspective, the famous founder effect, when modern humans left Africa roughly 60,000 years ago, cost us only about 15%. Losing nearly 2/3 of our diversity has left lasting scars. It's why humans are unusually vulnerable to certain diseases, why our immune systems are weaker than those of other primates, and why genetic disorders that should be rare are surprisingly common. In a twisted way, our fragility is proof of our greatest triumph. Every genetic weakness we carry is a reminder that our ancestors survived when survival seemed impossible. And survival was only the beginning. Around 813,000 years ago, something shifted. The human population didn't just recover, and it exploded. Within a few thousand years, the descendants of those survivors spread across Africa and beyond. They began developing new technologies, crafting more sophisticated tools, hunting larger prey with greater skill. They built shelters. They mastered fire on a new level. Humanity wasn't just enduring anymore, it was thriving. Most importantly, the end of the bottleneck marked the beginning of an evolutionary journey that would eventually give rise to 3 of the most successful species in human history: modern humans, Neanderthals, and the mysterious Denisovans. The timing is too perfect to ignore. Genetic evidence suggests that the last common ancestor of all 3 species lived right as the bottleneck ended. It's as if that near extinction didn't just test our ancestors' survival skills, It transformed them. It forged a lineage stronger, smarter, and more adaptable, one that wouldn't just survive in a hostile world but ultimately dominate it. Ye Huanpan, one of the scientists behind the discovery, explained it this way. The novel finding opens a new field in human evolution because it evokes many questions, such as the places where these individuals lived, how they overcame the catastrophic climate changes, and whether natural selection during the bottleneck has accelerated the evolution of the human brain. That last point is key. Natural selection under extreme pressure. In large populations, evolution moves slowly. Beneficial traits take hundreds of generations to spread, while harmful ones linger before disappearing. But in a population of just 1,280 individuals, evolution runs at lightning speed. A single helpful mutation could sweep through the entire group in just a few generations. Slight advantages in survival or reproduction meant the difference between life and death, and they rapidly reshaped the gene pool. For 117,000 years, our ancestors lived in an evolutionary pressure cooker. Only the toughest, sharpest, most adaptable survived long enough to pass on their genes. Generation after generation, natural selection honed the very traits that would later define humanity: problem-solving ability, cooperation, tool use, communication, and the capacity to learn and adapt in the face of change. The bottleneck wasn't just something our ancestors endured. It was the crucible that refined them, and ultimately us. It was more than survival. It was transformation and the crucible that made them and us who we are. But what did that actually look like? Living through 117,000 years of evolutionary hell. Let's go back. Way back, it's 930,000 years ago and the world is ending. Not with fire or an asteroid strike, but slowly, brutally, one failed harvest at a time. You're part of a small band of early humans, maybe 30 or 40 individuals. Your species doesn't even have a name yet. Homo erectus? Homo heidelbergensis? Scientists still argue about the labels. What matters is that you're human enough that thousands of generations later, your descendants will become us. Right now, though, you're watching your world vanish. Forests where your parents once hunted are shrinking into scrubland. Scrubland is withering into desert. Rivers that once ran year-round are seasonal trickles, and then nothing but cracked mud and dust. Your band is always moving, chasing water that keeps drying up, chasing herds that keep getting smaller, chasing a hope that keeps slipping away. This isn't a drought. Droughts end. This is the new normal. The Earth's orbital patterns have shifted into a nightmare. Vast ice sheets are growing in the north, locking up so much water that sea levels plummet by hundreds of feet. The Mediterranean shrinks into a scatter of smaller lakes. Land bridges rise between continents. But it isn't the ice itself that's killing your people. It's what the ice does to Africa. Those massive ice sheets warp the climate, creating an atmospheric dam. The monsoon rains that once pulsed across the continent, feeding rivers, nourishing ecosystems, weaken and falter. Year after year, the skies stay dry. And Africa, the cradle of your kind, begins to starve. What was once woodland shrank into grassland. Grassland hardened into desert. And desert gave way to nothing at all. Scientists have a word for what gripped Africa during this era: aridification. The continent didn't just get drier. It became catastrophically dry. Fossil records show that most of the great mammals vanished. Antelope species that had thrived for millions of years disappeared. Elephant populations collapsed. And when the big animals die, everything else follows. Predators starve. Scavengers starve. And for early humans who relied on both hunting and scavenging, the choices narrowed to just two: adapt or die. Most didn't make it. But your band, your fragment of the 280 survivors scattered across the continent, found something the others missed. Maybe a mountain range that still caught rainfall, maybe an underground aquifer feeding hidden springs, maybe a rift valley that generated its own microclimate. Whatever it was, it kept you alive, and it worked for 117,000 years. But working didn't mean progress. Forget the tidy diagrams of human evolution marching steadily toward bigger brains and better tools. There was no march during the bottleneck. There was only survival. Your world was small. Groups of 20 or 30 individuals, extended families, everyone related within a few generations. With only about 1,280 breeding humans alive on the entire planet, you couldn't afford to be choosy about partners. Inbreeding was inevitable. Genetic disorders would have been common, birth defects, reduced fertility, developmental problems, the price of such a shallow gene pool. And still you endured. Life was brutally simple. Wake up, find water, find food, don't get killed. Repeat. For 100,000 years, water was always first. In a land where most rivers ran dry for half the year, knowing where to find a spring or seasonal pool meant the difference between life and death. Your people probably developed an almost supernatural ability to read the land, to sense where water hid beneath the surface, to know which seasonal streams would last longest. Maybe you learned to dig simple wells, scraping out holes with sticks and stones. Crude but enough. Even a shallow pit that reached groundwater could keep a family alive through the dry season. Food was harder. With most of the large game extinct, hunting the way your ancestors once had was no longer an option. So you became what anthropologists call dietary generalists. You ate everything. Insects, always insects, termites, crickets, beetle larvae, pound for pound. Some of the most nutritious food sources on Earth, and they reproduce fast enough to harvest again and again. Roots and tubers became staples too, hidden underground where the drought couldn't touch them. You learned which plants were edible in which season, which needed to be roasted or soaked to neutralize their toxins, which could be stored away for leaner times. Eggs offered another lifeline. Bird eggs, reptile eggs, anything you could find. You likely learned to track nesting grounds, timing your raids to maximize food without destroying the next generation. And every once in a while, when luck tilted your way, there was meat. Not the great mammoths or giant beasts your ancestors once hunted in coordinated groups. Those were long gone. But smaller animals, the ones quick enough and cautious enough to survive. Catching one meant a feast, a young antelope separated from its herd, an injured zebra, an old elephant collapsing from thirst. These were your chances. And this is where fire became the dividing line between survival and extinction. Early humans had known fire for hundreds of thousands of years, but during the bottleneck it became indispensable. Cooking meat didn't just make it taste better, it made it safe. Parasites, bacteria, pathogens that could wipe out an entire band were destroyed in the flames. Just as crucial, fire unlocked energy. Heat broke down tough proteins and connective tissue, releasing more calories from the same chunk of meat. Cooking plants was an even bigger revolution. Many roots and tubers are inedible or toxic when raw. Fire transformed them into rich sources of carbohydrates. Some researchers believe this was the moment humans first began processing plant foods systematically, turning famine foods into staples. But fire was more than food. Fire stretched the day. For most animals, nightfall is shut down. Predators hunt, prey hide, everything waits for dawn. But with fire, your people could push back the dark. You could repair shelters, shape tools, and share precious information, where water still flowed, where game had been sighted. Most of all, you could strengthen bonds. And bonds were everything. In a band this small, every life mattered. One lost adult could mean disaster. A handful lost to violence or disease could mean extinction. Conflict was unaffordable. So you adapted socially. You learned to cooperate at levels modern diplomats would envy, to share even when nothing was left to share, to settle disputes before they broke into violence, to tend the sick and injured instead of abandoning them. Most crucial of all, you learned to share knowledge. A discovered spring was everyone's spring. A new method for detoxifying a plant spread instantly through the group. A clever hunting trick became common practice within days. Information didn't just pass from one person to another. It became the glue that held your fragile band together. This wasn't kindness. It was survival. In a population this fragile, losing knowledge with a single death could be catastrophic. So your people became obsessed with teaching, not just basic skills, but everything. Where to find water in each season, which plants were safe, how to track animals, predict weather, shape and maintain tools. Children who absorbed these lessons quickly had better odds of living and later, of reproducing. Generation after generation, this relentless filter selected for intelligence, for memory, for teaching ability, for the capacity to absorb and transmit complex information. You were evolving into something new. Genetic evidence suggests that during the bottleneck, human brain size began to creep upward, not the dramatic leap that would come later, but measurable growth. Fossils from just after the crisis show cranial capacities larger than those before. It makes perfect sense. When survival depends on outsmarting an unforgiving environment, Natural selection favors bigger, more capable brains, even if those brains demand more energy in a world already starving. But it wasn't only raw intelligence that was sharpening. It was social intelligence. Living in bands of just a few dozen, generation after generation, you learned to read people like the land itself, their moods, their intentions, their secrets. Knowing when to trust, when to share, when to be wary could mean the difference between the group surviving or falling apart. This pressure forged one of humanity's rarest abilities, theory of mind. The understanding that other people have thoughts, feelings, and motives separate from your own. To us it feels ordinary, but in the animal kingdom it's vanishingly rare, and your ancestors weren't just developing it, they were perfecting it, under the most unforgiving conditions imaginable. The archaeological record from this period is painfully thin, but what survives is revealing. Tools grew more sophisticated but also more standardized, as if scattered bands had begun converging on the same designs, copying and refining each other's methods. Archaeologists call this cultural convergence. Similar stone tools appear in different regions at roughly the same time, hinting at something extraordinary. Communication networks. Not just trade in food or materials, but the exchange of techniques, ideas, and genes. Because those 1,180 survivors weren't huddled together in one safe valley. They couldn't have been. If they had been, a single catastrophe, a drought, a flood, a volcanic eruption, could have erased humanity forever. Evolution doesn't gamble like that. Instead, they were scattered in tiny groups of 20 or 30, separated by hundreds of miles. Each band lived on its own, but fragile lifelines of kinship, migration, and trade stitched them into a greater whole. Biologists call this a metapopulation structure, small groups constantly blinking in and out of existence, but the network itself persisting. It was a brutal game of survival, like whack-a-mole with droughts, plagues, and predators as the hammer. Some bands flourished for a while in lucky pockets of water and game. Others collapsed, starving or succumbing to disease. Yet the network endured. When one group vanished, migrants from another filled the void, carrying not just their bloodlines but their knowledge with them. For 117,000 years, this desperate cycle repeated. Entire generations lived and died in uncertainty, but against all odds, the lineage held on. And then around 13,000 years ago, the world began to shift. The rains grew more regular. Grasslands slowly returned where deserts had ruled. Herd animals recovered. The most extreme phase of the climate crisis was ending. But by then, your ancestors weren't the same beings who had entered the bottleneck. 117,000 years of unrelenting pressure had transformed them. They had become sharper, more cooperative, more resilient. They weren't merely survivors anymore. They were the raw blueprint for what would become the most adaptable species the planet had ever seen. They had tools and techniques their distant ancestors could scarcely have imagined. Sharper stone blades, controlled fire used with precision. New ways of preparing plants and animals to unlock every calorie. But the greatest innovation wasn't physical. It was social. They had built systems of cooperation, knowledge sharing, and teaching strong enough to carry survival strategies across generations. So when the climate finally began to ease, they were ready. The rebound was dramatic. Populations didn't just recover, and they exploded. Within only a few thousand years, the descendants of those 1,280 survivors spread across Africa and pushed outward into Europe and Asia. Everywhere they went, they carried the hard-won lessons of the bottleneck: how to find food in impossible landscapes, how to manage fire, how to rely on one another when survival demanded it. These weren't ordinary humans. They were forged in the crucible of the worst climate crisis our species had ever endured. Every one of us alive today carries the imprint of that ordeal. Genes shaped for intelligence, cooperation, adaptability, all selected under pressures so intense that most species would have vanished. We are living proof that a handful of survivors can hold the line until the world becomes livable again. But the bottleneck wasn't the end of the story. It was the beginning of a new one. Imagine it. Your ancestors, after more than 100,000 years of hovering at the edge of extinction, see the world shift. The skies darken with rain clouds that haven't appeared for millennia. Dry riverbeds stir and trickle, then surge. Grasslands reclaim the deserts, green spreading across Africa like a second chance. The survivors are ready. And what happens next will change everything. Standardization was a quiet revolution. It meant that tools weren't just being invented in isolation, they were being taught, copied, and refined across generations. In Africa, this paved the way for the eventual rise of Homo sapiens, with stone industries like the Acheulean and later Middle Stone Age technologies showing clear leaps in precision and planning. In Europe, Neanderthals were doing the same. Their Mousterian toolkits included finely shaped scrapers, spear tips, and cutting blades, all crafted to exacting standards. They weren't just using whatever worked in the moment. They were developing traditions of craftsmanship, passing down methods that turned stone into something close to an industrial product. And in Asia, though the evidence is sparser, Denisovans likely had their own tool-making traditions, adapted to the vast range of environments they occupied. The few artifacts associated with their sites suggest they, too, were innovating, and their genetic legacy implies they were skilled enough to thrive everywhere from frigid Siberia to tropical islands. Across 3 continents, human populations separated by distance and environment were independently arriving at the same breakthrough: technology as culture. Tools weren't just objects. They were knowledge encoded in stone, carried in memory, transmitted through teaching. And once a species begins relying on cumulative culture, knowledge that builds generation after generation, evolution changes direction. Survival no longer depends only on biology. It depends on ideas. What began as survival strategies were evolving into the first outlines of culture, economy, and even proto-politics. Extended families weren't just cooperating within their own bands. They were forging ties with distant groups, exchanging mates, sharing technologies, and trading materials like obsidian, shells, or pigments across vast distances. These networks acted like insurance policies. If one group's territory suffered drought or game collapse, allies could provide resources or refuge. This was more than clever survival. It was the birth of interdependence, the realization that humans could buffer themselves against nature's chaos by leaning on one another. In Africa, these growing networks laid the foundation for symbolic communication: beads, pigments, and engraved objects that hinted at status, identity, or shared beliefs. In Europe, Neanderthal burials and art-like markings on cave walls suggest similar symbolic worlds were emerging. In Asia, the Denisovans' genetic imprint hints at deep medical knowledge and possible early domestication of plants, ideas that would one day explode into full-scale agriculture. For the first time in history, humans weren't just adapting biologically to their environments, they were reshaping their environments and each other through culture. Stone, fire, medicine, trade, ritual, these weren't isolated inventions. They were parts of an accelerating feedback loop where each generation inherited not only genes, but knowledge. This was the real legacy of the bottleneck. The catastrophe had compressed our species into its leanest, toughest form, and when the world finally gave us breathing room, we didn't just spread. We began building the first faint scaffolding of civilization, and so language, true language with grammar, nuance, and infinite flexibility, likely emerged as the greatest adaptation of the post-bottleneck world. It wasn't just about naming things or shouting warnings. It was about weaving memory into narrative, turning raw experience into transferable knowledge. With words, you could describe how to nap a spear point, warn of a predator's hunting pattern, or map the path to a hidden spring 2 valleys away. Language allowed groups to coordinate hunts with precision, to negotiate alliances, to settle disputes without bloodshed. It allowed parents to teach not only what to do but why, giving children tools to solve problems they hadn't yet faced. It allowed myths, rituals, and shared identities to take root, binding people together with stories that stretched beyond individual lifespans. The genetic bottleneck had stripped humanity down to its barest thread. Language spun that thread into a web, a network of communication that stretched across space and time. Once speech took hold, human culture could accumulate in a way that no other species ever had. Knowledge was no longer tied to a single lifetime. It could survive its creators. This was the true revolution. Fire, tools, hunting strategies, all of those mattered. But language turned survival into civilization. It was the multiplier that ensured every hard-won lesson of the bottleneck would not only endure, but evolve. Imagine it. two branches of the same ancient tree, separated for nearly 500,000 years, standing across from each other. On one side, the Neanderthals, stocky, powerful, adapted to the cold, armed with heavy spears and the knowledge of Ice Age survival. On the other, the newcomers from Africa, taller, more gracile with lighter tools, more flexible strategies, and a language refined by countless generations of bottleneck survival. The air between them would have been charged with uncertainty. Friend or foe, kin or rival, these were not encounters of predator and prey, but of equals, beings who recognized something deeply familiar in each other's faces. Same eyes, same hands, same spark of intelligence, and yet different enough to provoke fear. We don't know whether the first contact was violent, peaceful, or something in between. But we do know what followed, a long, complicated dance of conflict, trade, interbreeding, and cultural exchange. Modern human DNA today carries the signatures of those meetings. Neanderthal genes for immune system function, Denisovan genes for high-altitude survival. The evidence is clear, they fought, but they also mingled. They competed, but they also shared. But in the long run, cooperation gave way to domination. Within a few tens of thousands of years, the Neanderthals and Denisovans were gone, absorbed into the human genome but erased as independent peoples. Only one lineage remained. The world had entered a new era, not the age of survival, but the age of expansion. And the humans forged in the bottleneck were about to prove unstoppable, until something shifted, not in the land, but in the minds of modern humans. Around 50,000 years ago, evidence shows a sudden leap in creativity, technology, and culture among our ancestors. Cave art, musical instruments, complex ornaments, and finely crafted tools appear almost simultaneously across Africa and Eurasia. This wasn't just survival anymore. It was imagination, symbolism, abstract thought made visible. Anthropologists sometimes call this the Great Leap Forward. For Neanderthals, who had thrived for hundreds of thousands of years in Ice Age Europe, the change must have been bewildering. They were skilled hunters, masters of their terrain, and they had intelligence on par with ours. But the modern humans arriving from Africa carried something different: flexibility. They could adapt their tools to new environments faster, form wider networks of trade and kinship, and share knowledge with astonishing speed. The revolving door of the Middle East began to swing in only one direction. Each time the climate shifted, modern humans returned with more sophisticated technologies and stronger social bonds. Eventually, Neanderthal populations began to dwindle. Isolated groups survived in scattered pockets, caves in Spain, valleys in the Caucasus, but their world was shrinking. Interbreeding still happened, passing precious survival genes into the modern human lineage. But gene flow couldn't halt the tide. By around 40,000 years ago, Neanderthals were gone as a distinct species. Not vanished, not entirely. Their DNA lives on in billions of people today, but erased as a people.
Folded into the story of modern humanity, and just as one cousin disappeared,
another, the Denisovans, waited further east. Weapons once used against mammoths and bison were now turned on each other. Archaeological sites from Europe and the Near East bear grim witness. Fractured skulls, embedded spear points, settlements burned and abandoned. For tens of thousands of years, Neanderthals and modern humans had coexisted, sometimes trading, sometimes interbreeding, sometimes avoiding one another. But after the rise of the Upper Paleolithic toolkit, the balance tipped. Modern humans had numbers on their side. Their populations were growing faster thanks to greater hunting efficiency, more reliable food sources, and wider social networks. They had innovation on their side, tools that could be redesigned, adapted, and spread rapidly between groups. And they had resilience on their side, symbolic culture, rituals, and language that bound groups together and kept knowledge flowing across generations and landscapes. Neanderthals, meanwhile, were being squeezed. As modern humans pushed into their hunting grounds, the margins of Neanderthal life shrank. Competition for prey intensified. Climatic fluctuations hit already dwindling populations hard. Some Neanderthal groups likely allied temporarily with modern humans, even merging through interbreeding. Others fought back, leaving behind signs of brutal conflict. But in the long run, the advantages of modern humans were insurmountable. By 40,000 years ago, Neanderthals had disappeared from most of Europe. The last remnants held out in isolated refuges like caves in Gibraltar, until about 30,000 years ago. Then they too vanished as a distinct people. Yet they were not erased. Every person alive today outside of Africa carries the genetic traces of those encounters. Adaptations for immunity, metabolism, even brain development. Neanderthals may have lost the competition, but they live on in us. And while modern humans claimed Europe, another meeting loomed further east. One with the Denisovans, whose genetic legacy would ripple across Asia and the Pacific. The Denisovan encounter unfolded on a different stage, but the themes were familiar: contact, exchange, and competition. Unlike Neanderthals, Denisovans are known almost entirely through fragments. A tooth here, a finger bone there, and most importantly, their DNA. That genetic record reveals they were widespread, ranging from the cold highlands of Tibet to the tropical forests and islands of Southeast Asia. When modern humans moving east out of Africa met them, they didn't just clash, they mingled. Multiple episodes of interbreeding left deep marks in today's populations. People in Melanesia, Australia, and parts of Southeast Asia still carry up to 5% Denisovan DNA, far more than the Neanderthal contribution in Europe. In Tibetans, Denisovan genes underpin adaptations for high-altitude life, helping them thrive in the thin air of the Himalayas. In other groups, Denisovan DNA shaped immune responses and metabolism, providing advantages that persist to this day. But just like with Neanderthals, cooperation and interbreeding were not enough to save them. As modern humans expanded, Denisovan populations fragmented. Some were absorbed genetically, their lineages blending into the newcomers. Others dwindled in isolation, unable to compete against the flexible, fast-reproducing, technologically innovative humans spreading across their lands. By 30,000, 40,000 years ago, Denisovans as a distinct people were gone, just like their cousins in Europe. Still, they too survived within us. Every breath taken on the Tibetan plateau, every immune response shaped by ancient DNA, is a reminder of their legacy. Together with Neanderthals, Denisovans ensured that modern humans did not emerge alone, but as the final branch of a tangled family tree, one pruned by competition, but enriched by deep genetic exchange. From that point forward, only one human species remained on Earth, but it was a species carrying within it the fragments of all those who came before. Exactly, and the answer loops right back to the crucible that almost wiped us out. Modern humans didn't just get lucky. Our ancestors were forged during those 117,000 years of near extinction, a period when only the most adaptable, cooperative, and innovative individuals could survive. That evolutionary pressure cooker selected for a very particular survival strategy, not brute strength like the Neanderthals, not narrow specialization like the Denisovans, but flexibility. That flexibility expressed itself in three key ways. Technological adaptability, where Neanderthals perfected a toolkit optimized for Ice Age Europe, and Denisovans refined specialized survival strategies for highlands or seafaring. Modern humans developed technologies that could be endlessly modified. Spear throwers, nets, clothing, fire control, food processing. These weren't just tools. They were platforms for innovation. If the environment changed, the tools could change with it. Social scalability. Modern humans inherited from the bottleneck not just the capacity to live in tiny, cooperative bands, but also the ability to scale those bonds outward into larger networks. Kinship rules, trade systems, rituals, and eventually language allowed groups to form alliances and share information across vast distances. Neanderthals and Denisovans had culture, but Homo sapiens had culture that could expand. Cognitive versatility. The bottleneck didn't just refine intelligence, it supercharged social intelligence. Reading others, teaching children, passing down oral traditions, and ultimately, creating symbolic systems like language and art. This made Homo sapiens uniquely equipped to solve problems collectively, to transmit complex knowledge, and to innovate rapidly. So when modern humans met their cousins, they weren't necessarily stronger, faster, or even inherently smarter. They were more adaptable. The very traits that had once allowed 1,280 survivors to cling to life in scattered African refuges now allowed their descendants to spread across the globe, thrive in every environment from tundra to desert to rainforest, and ultimately become the last humans standing. By 20,000 years ago, the experiment of multiple human species sharing the planet was over. Only Homo sapiens remained. But inside us, in our bones, in our blood, in our DNA, are the echoes of all those other humans, from the Neanderthals and Denisovans who shared our genes, to the anonymous few who kept the flame alive during the Great Dying nearly 1,000,000 years ago. We are, every one of us, living proof of that. Survival, exactly. Diet was one of the most important expressions of that flexibility. While Neanderthals were apex hunters of Ice Age megafauna and Denisovans seem to have specialized in certain ecological niches like high-altitude resources or seafaring-based subsistence, modern humans became dietary opportunists on a whole new scale. They ate everything, big game when available, but also fish, shellfish, small mammals, birds, reptiles, insects, roots, tubers, nuts, fruits, seeds. Archaeological evidence shows Homo sapiens exploited a broader range of resources than any other human species. That mattered for two reasons: stability in unstable environments. When droughts killed off grazing herds or floods changed landscapes, Neanderthals or Denisovans who relied on specialized food sources would struggle, but modern humans could pivot. If large animals vanished, they trapped rabbits. If fish were plentiful, they built nets. If plants were abundant, they processed roots and grains. This ability to switch strategies quickly made them resilient in ways other species weren't. Population growth. A broader diet meant a more reliable calorie base. Reliable calories mean higher fertility and lower mortality. That's why modern human populations could grow faster and recover more quickly after disasters. A single failed hunting season wouldn't doom them, because they had fallback foods. This dietary generalism, combined with social cooperation, rapid innovation, and flexible problem-solving, is what turned modern humans into true global colonizers. Once they left Africa, they weren't limited by environment. They could thrive on the tundra, in deserts, in rainforests, even on islands. No other human species had that kind of adaptive toolkit. In short, those 117,000 years of hardship had forged a lineage that could survive anything, not by being the strongest or the smartest in one domain, but by being just adaptable enough in every domain. That's why when the competition between species began, modern humans steadily expanded while Neanderthals and Denisovans, for all their strengths, eventually dwindled. By 15,000 years ago, modern humans had spread to every continent except Antarctica. They had developed agriculture, permanent settlements, and complex societies. What had begun as scattered bands of hunter-gatherers had become villages, then towns, and eventually cities. The flexibility that once allowed our ancestors to adapt to shifting climates and elusive prey now fueled the construction of irrigation systems, the domestication of plants and animals, and the rise of trade networks that spanned continents. The true advantage of modern humans was no longer just survival. It was scalability. Language, culture, and cooperation allowed small family groups to expand into tribes, tribes into chiefdoms, and chiefdoms into civilizations. Knowledge no longer died with the individual but was stored in stories, symbols, and later writing, compounding across generations. By reshaping landscapes, taming rivers, and cultivating fields, humans were no longer adapting to the environment alone. They were bending it to their will. The bottleneck had selected for survival under desperate conditions. But what emerged from it was a species capable of transcending those conditions entirely. That's the part that stops you cold when you really think about it. Every skyscraper, every symphony, every whispered word between lovers at night, all of it exists because a handful of humans endured against impossible odds. They didn't know they were carrying the fate of the species on their shoulders. They were just trying to survive the next storm, the next drought, the next hungry predator. But in holding on, they gave us everything. It makes you wonder, what will we pass on? We are their legacy, but we are also the next bottleneck in waiting. Climate change, resource depletion, even the technologies we create, each could test whether the adaptability that saved us once can save us again. The story of humanity is not finished. It is still being written line by line, choice by choice. And just as those 280 survivors could never have imagined cities glowing like galaxies, We cannot yet imagine what those who come after us will inherit. What we do know is this: if history has taught us anything, it is that even when the thread is thin, humanity has a way of holding on. Ever wonder why humans are such compulsive storytellers? Why we spin myths, write novels, make movies, share gossip late into the night? It's because during the bottleneck, stories weren't entertainment. They were survival guides. A tale about where to find water, how to avoid a poisonous plant, or what happened the last time the rivers dried up could mean the difference between life and death. The ability to remember and retell those lessons became one of our most powerful tools. Ever wonder why we're endlessly curious? Always pushing into new frontiers, asking questions no other species bothers to ask? It's because curiosity was a survival strategy. Populations that explored beyond the next ridge, that experimented with new foods or tools, were the ones that endured when conditions changed. Curiosity isn't a luxury, it's an evolutionary inheritance. Ever wonder why love and empathy feel so overwhelming, so hardwired into us? Because for 117,000 years, the only way fragile humans could endure was by caring for one another. Infants took years to grow. The sick needed tending, the elderly carried precious knowledge. Those who could nurture, who could feel the pain of another as their own, were the ones whose families made it through. His is excellent. You've woven the strengths and the vulnerabilities of humanity back into the same evolutionary thread. By showing that the bottleneck didn't just make us adaptable but also left us fragile in certain ways, you've given the story real balance and depth. If you want to keep building this section, you could round it out with a few more. Ever wonder why? Reflections that touch on universal human quirks, tying them back to those 117,000 years. For example, ever wonder why humans crave belonging so intensely? Why exile or loneliness feels unbearable? In the bottleneck, isolation was death. A single human cut off from the group had almost no chance of surviving. Our brains rewired themselves to treat rejection as physical pain, to push us toward cooperation no matter the cost. Ever wonder why we struggle with anxiety and overthinking? Why our minds so easily spiral into imagining worst-case scenarios? Because in an unstable, punishing world, caution was survival. Those who worried about every rustle in the dark, every shadow on the horizon, were the ones who noticed real threats first. That vigilance kept their families alive and left us with brains wired for stress. Ever wonder why we're so restless, always reaching for more? Why humans don't just settle into stability the way other animals do? Because during the bottleneck, stasis was dangerous. Environments shifted constantly. The groups that pushed beyond the next valley, that tried something new instead of repeating the old, were the ones that survived. Our hunger for progress is the echo of their desperation. When humans migrated out of Africa 60,000 years ago and spread around the world, they carried bottleneck DNA to every continent. Over time, groups adapted to local environments. Darker skin in the tropics to protect against UV, lighter skin in northern latitudes to produce vitamin D, differences in hair texture, facial structure, even metabolism. But these are surface-level tweaks, cosmetic adjustments layered on top of the same ancient genetic foundation. Underneath, we are shockingly alike. That's the real revelation of the bottleneck. We are one family. The divisions we obsess over, race, nationality, culture, are recent inventions. They're measured in centuries or millennia, while our shared genetic story stretches back almost 1,000,000 years. Every person alive today is the product of the same near-impossible survival story, the same fragile thread of continuity that almost snapped but didn't. Think about that the next time you look at a stranger. Their ancestors and your ancestors were the same people once, huddled around the same fires, whispering the same survival lessons to their children, clinging to existence when the world seemed determined to erase them. The differences we see now are a thin layer of paint over a structure built from the exact same materials. The species that turns desperation into innovation, scarcity into cooperation, and crisis into opportunity. The bottleneck didn't just shape our biology, it shaped our identity. Every invention, every culture, every city glowing against the night sky is proof of what those 1,080 survivors made possible. Their story is our story, and it carries a message. Survival is never guaranteed, but neither is collapse inevitable. As long as we remember who we are, the descendants of people who refused to give up, there is no challenge we cannot face, not metaphorically, literally. Their DNA runs through your veins. Their choices echo in your instincts. Their resilience is the reason you are here reading these words. You are their proof of concept, their legacy made flesh. We are not separate from them. We are them, stretched forward through time, carrying the same fire, the same determination, the same refusal to quit. Those 280 never disappeared. They are alive in us, 8 billion strong, and the story of those 280 survivors is still being written. Every challenge we face, the climate change, pandemics, conflict, the unknowns of the future, is another chapter in the same tale of endurance. We carry their genes, their instincts, their unbreakable will. The bottleneck did not end their story. It began ours. And as long as we keep adapting, keep learning, keep cooperating, the line that started with them 900,000 years ago will keep flowing forward into every tomorrow.